You might be browsing the website, suddenly somebody gives you a URL, you click it, and then you've lost your account.
The one concern I have is I don't want to go to your website now.
We are taking over the world before you know it.
Hey everyone, it's David Bumble back with a very special guest. Wesley, welcome.
Thank you very much, David.
Can you tell us what handle you well known for on Twitter and on other platforms, and tell us why you use that handle?
So I usually use the handle the XSS Rat. It started because I have a fascination with exotic animals that not a lot of people like rats, and I have like a bearded dragon and a spider here. I have those kinds of pets, and rats are really intelligent animals. They're more intelligent than cats and dogs. You can teach them a lot of tricks. And if you can teach them cross-site scripting, that would be amazing. So I was like, let's start teaching rats cross-site scripting. But it didn't turn out that way. So why not be a rat and then teach myself cross-site scripting? No, just kidding. Of course, like a rat is also a remote access tool. First of all, I really do like rats. That wasn't a joke. But cross-site scripting remote access tool has been a fantasy of mine. Like, okay, if I can do cross-site scripting, maybe I can escape that somehow and turn it into a remote access tool. It's just a crazy fantasy of mine, but maybe one day, who knows?
That's fantastic. So, I mean, can you explain what cross-site scripting actually is? And perhaps in this sort of interview, give us a demonstration.
I think there's a lot of misconceptions out there about cross-site scripting. Like if I go online right now and I look up cross-site scripting, I can find at least 4 mistakes in the first page. And the problem with cross-site scripting is that a lot of people, first of all, think it's only in JavaScript. That's not true. Cross-site scripting basically means that I, as an attacker, can insert a script in a website, a piece of script that's going to execute on your computer. And that piece of script can happen in any scripting language, like the notorious Flash, for example. It's an exploit in and of itself, but besides that, cross-site scripting is very possible there as well. And we don't use that anymore, of course. It happens predominantly in JavaScript because JavaScript is the predominant scripting language. It's as simple as that. Basically, it happens because a developer doesn't sanitize user input properly. And even if they sanitize user input to a degree, there might still be cross-site scripting possible. So if you have a script on your website, or it's just a normal website, and I insert a piece of HTML that says script, and then my script in there, and then /script, that basically can execute if you don't sanitize it properly. I'll show you guys what I mean by that. But I first need to talk a little bit about the types of cross-site scripting out there. Because a lot of people think that reflected and stored and DOM cross-site scripting are the predominant types of cross-site scripting. So you have stored cross-site scripting, which means that I, as an attacker, insert a value into the website and then stores it somewhere on a database or in a file or whatever, and then displays it again. I can also have reflective cross-site scripting, which doesn't touch the server. I send you a link and it contains the attack. And then also DOM cross-site scripting. And when you have a website, you have the website itself, the source code, like we can see. And then you have the DOM, which is everything around the website itself, the document object model. Things like the history, the link, things that describe your website, basically. And you can, from the source code, enter a value which enters the document object model. And that happens due to a DOM sync, as we like to call it. Now, a DOM sync, I can show you that later on as well, basically means I take a value from my source and I enter it into my document object model. Like if I have to take a piece of if I have to take user input and enter it in a URL, for example, that can happen through DOM or document.write. There's a lot of DOM things out there and a lot more in jQuery even. Now, I don't want you to worry too much about that because that's already pretty complicated. I'm going to keep it a little bit more simple today and talk only about source cross-site scripting. We have reflected source cross-site scripting and stored cross-site scripting on the source, but that also happens on the DOM. We have reflected DOM cross-site scripting and stored DOM cross-site scripting. Besides that, we also have blind cross-site scripting, and in recent years, mutated cross-site scripting. So there's a lot of types of cross-site scripting out there. I'll predominantly focus on source reflected and source stored. So the most basic types of cross-site scripting, basically. On hexpert.com/labs, you can find a lot of labs that I've created. These are the reflected cross-site scripting labs that I was talking about, but there's a lot more on here, of course.
To make sure that everyone's on the same page, you've got a basic HTML page here that you wrote in PHP, is that right? And then it asks for user input. Now, normally, we would just put user data there, like John is your first name, and that would reflect it in the URL like you've shown there, yeah? But what you're saying is you can, rather than just a username like data, I can like try and execute JavaScript there. So that's where you use the script thing, is that right?
Exactly. So this user data is being reflected into my source code right here.
Yeah.
But I can enter anything in here. It doesn't have to be John. It can also be a script, for example, or a broken image with a script on it.
Just for people who don't know JavaScript, that script implies that it's going to run some JavaScript, and then alert means it's going to pop something to the screen. Is that right?
Exactly. So script is a JavaScript, like you said, and alert is going to make that pop-up appear. Now, I talked about sanitizing user input before. The script tag is being sanitized. As you can see, nothing is reflected. So the developers have gone as far as to remove that script tag. So that would be a basic tag. If the developers filter nothing at all, that script would pop up an alert right here, a little alert box.
You've got a div class, so you've created like a piece of code, and in there you're saying alert equals $0. Is that how you're stopping alert from doing something?
It is because there's no script in here anymore.
Okay.
So if I show you the source code of this page, it would say remove anything that says script, the string script, remove that completely. For example, if I do script A in here, you can see that it removed script and only left A.
Oh, I see, yeah. So you're looking for that word script and then stripping it out, basically.
Exactly. That's a very basic defense against cross-site scripting. But it doesn't stop things that don't contain the word script in it. And on a HTML tag, this is an HTML tag, for example, an image with a source. And I can say, this image is located at this location, but I can also say X to make it a broken image. So now I'm inserting a HTML tag in here with a broken image, as you can see. And that was also reflected in here. You can see, if I go here, I have created an image tag.
Yeah, so we see the image just above first name, but the image is obviously broken. So what you're saying is, and if you can just show us that code again, image, if broken, then on that error, do something, and that's how you got the alert, yeah?
Exactly. This is what we call a event handler, a JavaScript event handler. We can have HTML tags, and on there we can have event handlers, like an onload event, for example, which means that if this item loads, execute this code in here. And I've chosen to pop up an alert, and if I execute this, I can see, it's a little bit hard to see. I'm going to close my source code for a second. You can see pop-up appear over here.
So basically the vulnerability here is in traditional HTML, we've changed HTML over the years to allow scripts to run within HTML, but that allows someone malicious like you to basically run code to do something that the developer didn't think would happen originally, yeah? So you're basically injecting code and the web server, whatever, is just running that code and you getting it to do something. And like a pop-up, like you say, is kind of pointless, but you could steal credentials. Is that right?
Exactly. Like if we log into a website, we have many ways of authenticating. And one of them is a session cookie. And if I steal this session cookie PHP sesh ID, so I can demonstrate that as well, I can pop an alert which contains that session cookie document. Cookie. And as you can see, right now I've popped up an alert. It's the same attack that I did before, but now I'm including the cookies in here.
So just for people who are not sure, what does a cookie do? This contains the session information. So if I have that, I can connect to the servers if I'm you. Is that right?
Exactly. This PHP session ID basically identifies me. This says that I am Wesley. And if you steal that, you can be Wesley as well. You can log in as me without actually knowing my password.
Let's use you and me as an example. I'm looking at my bank statements through an app or whatever. If you steal that session information, if the bank hasn't done it right, you could basically take over that session, have access to all my bank account details, and then you could take money out of my account, something like that, yeah?
Exactly.
Wow, okay.
It can be a very dangerous tag, this one. A lot of developers have tried filtering over the years, and there's a lot of filters possible for this. But the problem is that cross-site scripting is a very varied and deep attack that not a lot of people understand correctly. This was a very basic attack vector where I literally insert anything that you put into that field into the HTML source code. If I send a cross-site scripting reflected cross-site scripting attack, I can just take this URL with the attack vector in it and send it over to you, David. And if you open this URL, I have your cookie.
So like you could send me an email, it's like a phishing thing type thing, and I click on that, you've got it, yeah?
Exactly. You might be browsing the website, suddenly somebody gives you a URL, you click it, and then you've lost your account, and they can send emails as you maybe even, or messages as you, who knows. This is very dangerous as an attack vector. And right now, it seems like nothing is reflected right here. But if you look real closely and you inspect source code, you can still find this item that I've put in here in the source code, but it's an HTML comment. This is not a very common thing to occur, but if your user input does get reflected in an HTML comment, I can also break out of this by just ending this comment. So an HTML comment is indicated by a greater than sign and then a exclamation mark and then 2 dashes. And to escape that, to end that, I enter 2 dashes and this is a less than sign, of course, and a greater than sign. And now I've broken out of this comment. So anything that I enter now is not going to be reflected in the comment anymore, but it's actually going to be reflected on the page. And then I can still perform my attack vector like I normally would and get that pop-up to appear for me.
The reason that you're doing this is the code was perhaps not written right. Is that correct? The developer didn't write the page correctly, and you're just circumventing that.
Exactly. The developer just assumed that maybe there is the piece of, let's say the developer created this, and he reflects your input into the page somewhere, but also in an HTML comment. If he's filtering out the page properly, that's good. But if he's then not filtering out the comment properly, you still have an option to escape it. This is just a very simple attack vector again, but this is out of the way. This is not something that you see a lot. That's the problem with cross-site scripting. It's often things that you don't see a lot that are most dangerous. For example, this is also an attack vector, but if I enter this one, you can see that my input gets reflected into a input field. Now you might be thinking, okay, if I enter just the script like I entered before, it just gets reflected into the input field. Nothing wrong here because in the input, this doesn't execute. But the problem is that I can then break out of this input again. You can see here input value equals and then a double quote and then what I just entered. So let's say I enter a double quote. I enter it myself, then I stop this value here. This input tag is terminated, especially if I enter this in here. You might think now I am outside of my input field, but you're not, because it looks like there's a double quote being used right here. But if I look at the PHP code, I actually used a single quote. So if I use my single quote here, now I do break out of my input tag. And this is the dangerous part because a lot of people might miss this cross-site scripting because they're only testing for a double quote. So if a pen tester only tests for a double quote here, he's completely missing this cross-site scripting vector. But there's still a possibility to execute it. So I'm breaking out of my input tag right here. I'm ending this value, and then I'm just going to enter the same attack vector that I always do, and I'm going to get a cross-site scripting pop-up again.
You demonstrating with a pop-up, that's just to make it simple, yeah? But you could forward that to another server or somewhere, is that right?
Exactly. This is always the proof of concept that people use because it's easy. If you're ever testing for cross-site scripting, I really don't want you testing with an alert. I want you testing with a prompt or with a with anything but alert. Every developer out there knows that we are testing with alert. So every developer is going to filter on alert. Instead of my alert here, I can enter a prompt as well. And while he might be filtering out the alert, he might not be filtering out the prompt.
This kind of looks like, okay, who cares? You're getting a prompt or an alert. But that's not the point. The point is you could do something a lot more malicious than what you're demonstrating here. This is just, as you said, proof of concept of the fact that you're doing something on a web page that the developer didn't expect and you're able to extract information, yeah?
Exactly. You guys see these parameters here. What I'm going to be doing is I'm going to be entering the cookies that I'm stealing. I'm going to be transforming that into a parameter. And then JavaScript can do a lot. JavaScript can make a request to my server, to my web server. And on my web server, I have what's called access logs. And I can check those logs and I can see that a request has been made with a certain parameter. And if you remember, that parameter is the cookies. I now have your cookies on my server in my access logs. And now there are protections against this. Things like CSP, for example. That's a header that is sent from the server to the browser. And the browser interprets the CSP header, and it says, for example, you cannot make this request, it's not okay, or you cannot execute this JavaScript, it's not okay. But those protections, again, can be circumvented if you don't implement them correctly. Like, for example, if the browser doesn't implement CSP headers, because this is purely a browser-based mechanism, if the browser doesn't interpret that, then you're out of luck. Then I can still execute my script. There's also a X cross-site scripting protection header that's mostly been made irrelevant because of the CSP headers. But older browsers only support the X cross-site scripting protection header. Now, the cool thing about that is you can actually introduce exploits by using that header.
In other words, let me just see if I understand it correctly. You can inject code onto a page that the user will run with locally, is that right? So this stuff gets executed locally on the client, and then you can get that client session information, all kinds of other information sent to your server and log that kind of thing, yeah?
Exactly. And the thing is, I can even insert a keylogger onto your computer if I'd like. Like if I cannot get your cookies, because as you can see, these cookies right here, they also have flags on them. Host only, session secure, and HTTP only. If the HTTP only flag is enabled, like I'm going to enable it right now and I'm going to try to steal my cookie again, it's not possible because that cookie doesn't get read anymore. That's a protection that a lot of people will use. So you can see that the PHP session ID cookie is no longer in here. That's because it cannot be read from JavaScript and I cannot steal it anymore as an attacker. But there's so much more I can do because every website these days contains a lot of JavaScript. And if I execute a JavaScript function on your computer and you are logged in, for example, the JavaScript function delete account, I am deleting your account. There's a lot more that can be done with cross-site scripting. If we talk strictly bug bounties, things like keyloggers and stuff like that is usually not accepted. You have to show some real proper impact. But even cryptocurrency miners, that's hot these days. You can be browsing a website unsuspectingly, because all I've shown right now is reflected cross-site scripting. But I can also store this attack vector. So I can either send you this URL, or I can go to get some stored cross-site scripting. I also have labs for that, of course. So this is stored cross-site scripting. And as you can see, I can log in right now. I can register. As you can see, I can make a post and other people can see my posts. So if you browse this website, you can see what I have posted. Now again, I can insert a cross-site scripting attack in here. And if you browse across this, you might have cross-site scripting being executed. And the thing is, you might be browsing a website unsuspectingly, like Facebook or Twitter, and without knowing it, stumble across a cross-site scripting attack vector. And I make it very obvious by popping an alert. But a real attacker wouldn't do that. They would silently install a cryptocurrency miner on that website. And you will come across it, and suddenly you have a cryptocurrency miner on your computer running all day and night.
This is perhaps a dumb question, but how do you as the attacker inject that code? Because here you manually doing it, but how does an attacker actually get that code to run on, like you said, Facebook? And we just use that as an example, but like any other website, how do you inject your code into that website so that when I go to that website, it runs?
This is the way. So I've been making a post right now, and my post has been cross-site scripting in this case. So again, a normal attack vector. And if you come across my code, my post, then that code is going to get executed on your computer.
You went to this website and you did something, and that got stored on the website. Now, if I go to that website afterwards, that code gets run.
Exactly. If you see my Facebook post, my code gets run on your computer. There's a famous example from this a while back on Twitter. There was a self-retweeting tweet. Everybody that stumbled across that tweet retweeted it because there was code being executed in the background.
Oh, okay.
That spread really fast.
You put code on Twitter or Facebook, whatever, they stored that code on their servers. So it's stored, hence the stored name. I go to that page as a client. I load that post. Instead of seeing a picture of cats, I'm now getting rat code that you wrote or doing something.
Exactly.
Yeah?
I'll show you an example of this as well. So let's say you're working in your environment, you log in, suddenly you are browsing your website, you come across this post, and bam, you have your code executed. This is also a website that I wrote, by the way, that everybody can go to. It's hexpert.com/ratsite. And in here, if you can register, you can log in and you can make yourself administrator. This is a very vulnerable website. But this contacts page, I just opened it. I didn't write any code as you saw. I just opened this page and bam, I get cross-site scripting executed. Somebody inserted this in here, and they were funny because they gave the answer to life and everything apparently in my cross-site scripting. But this is a very vocal example. This is not something which you will come across in real life. An attacker will try to be silent and try to not pop any alerts, but instead execute code or steal your cookies or, like you say, suddenly just replace all of the pictures of cats with rats. And we are taking over the world before you know it.
So I get the stored one. That makes a lot of sense. You go and post some code. Rather than me getting pictures of cats, there's like some kind of code that runs now and shows pictures of rats or something much more malicious. With Reflected, that's where you send me an email or something, and then I click on it, and that's how that executes. Is that right? I'm just trying to get in my head, how does the code actually run on like a Reflected one?
So you can see that I have a parameter in here, search term. I can literally send this to you, David, and you click on this and bam, you have your code executed. Of course, stored cross-site scripting is worse than Reflected, because in Reflected, I'm going to have to do some social engineering to get you to click on my link. Whereas stored, you just browse the website and bam, your code gets executed.
Well, yeah, it makes a lot of sense.
And I just showed you 2 contexts or 3 contexts. There's a lot of contexts that code can get executed in. A developer might be very secure in filtering out anything that is a attack vector like this, completely filtered out. But in here, there's still an attack possible, because this is what we use, Angular. This is a templating engine in JavaScript. AngularJS is what it's called. And I'm using a vulnerable version that allows for client-side template injection. If I do this, for example, 7 times 7, you can see that it gets converted to 49. It gets executed, and I can insert an attack vector like this. This is pretty complicated, of course. and you see that they still have a pop-up, even though the developer has been very secure and diligent in filtering out anything that they think of. If they still use a vulnerable version of a templating engine, I can still insert cross-site scripting. So just to demonstrate, it's so complicated and it's not something you can solve with a few simple steps. You really have to be diligent everywhere.
So the answer is don't run JavaScript on your website.
Or with JavaScript. No, JavaScript is making a real, it's getting really, like Node.js is coming up really big, and templating engines are making a really big introduction.
Yeah, I mean, it's not something that's going to go away. I say that as a joke because it's like saying don't use HTML. It's so important these days, isn't it? But the moral of the story is it gives attackers so many options to attack.
Yeah.
Or someone who's interested in like bug bounty gives them a lot of options. Yeah.
And I just want to say, know what you're doing. Don't put a developer on securing this if they haven't been trained properly in securing this, because this is not something very easy to fix. If you have a developer use a templating engine, make sure they know that templating engine inside and out, and not just somebody who is learning things off of Google and then throwing it into production. That doesn't work.
The more you talk, the more I think, man, I need to learn more about this. Do you have a course or something that someone can access, or how could they learn more about this?
Definitely. On Udemy, I have a complete course explaining all of these different attack types with several different contexts as well. It's a cross-site scripting course, Introduction to Cross-Site Scripting, called Introduction because there's so many things you can learn. But when you finish that course, you'll be proficient in hunting cross-site scripting in the passive way and in the active way. There's many different ways you can test for cross-site scripting, but I just like to keep it to passive, lazy way, not finding as much, and active, much more involved way, but being able to cover much less ground, still finding more.
That's great. I'll put a link below. So if anyone's interested in getting that course, they can purchase it below. What else did you want to show us?
So you were talking about DOM cross-site scripting as well. For DOM cross-site scripting, this one is more easy. Well, I say easier, but it's just one lab. That's what I have on it right now. I'm expanding these. But for this lab, you can see that I have a selection right here, a selector of different things that I can do. But I also have a script in here. And this is my Google script. So if I go look for a script, there it is. And this script, as you can see, uses the document.write. Basically, what I'm doing is I'm taking, and this is a very simple explanation, I am taking a part of the URL where I say default equals, and then I'm taking that item and I'm inserting it onto my page. So I just have to read this JavaScript carefully, and then I can say, for example, default equals 1. You can see that that is reflected in here. So it all comes down to source code review. Now, this is a super simple website. Not a lot of things on here at all. If you're dealing with a real website, JavaScript is a gold mine. That's what I want to give to everybody. Read the JavaScript code. There's so many good things in here. And if you know what to look for, like the DOM things, this is an example, document.write, you can insert DOM cross-site scripting into these different image source equals X. So as you can see, it's kind of breaking my code already. And you can insert a lot of attack vectors into the document object model as well and start from there. Your normal source-based cross-site scripting, which is where I literally just display the code into the source code, or I can enter the document object model through a DOM sync and then spit it back out as a DOM source in here, and then I can still have cross-site scripting possible. DOM cross-site scripting is one of the hardest types of cross-site scripting to look for. It's something that I would recommend you use a scanner to look for this. Scanners are very proficient in picking up this type of cross-site scripting, where humans are not. We literally have to look for all of the DOM things Sportswigger has a excellent article about this. You can see here document.write. That's the one that I've been using. But you also have document.writeLine, document.domain, inner HTML, outer HTML. And these are just the JavaScript DOM things. If you talk about jQuery, jQuery, by the way, for you guys who don't know that, it's also JavaScript, but it can do a lot more. It's basically like an extension of JavaScript. It has a lot more DOM things even. So you can see that all of these DOM things have the potential to lead to DOM-based cross-site scripting.
Just from a opportunity point of view, most websites use JavaScript these days. Is that right?
And and even jQuery or Ajax or a like TypeScript, those are all types of JavaScript, by the way. I know I'm oversimplifying this for the more technical viewers, but these are all extensions on JavaScript. For example, with Ajax, I can do live updates. Like if I have an auction, for example, and I'm on the website, I don't want to have to refresh my website to see if there's a new bid. So I can use Ajax to see if there's a new bid, and if there is, I can update my website. So that's also a version of JavaScript. And jQuery is known to have a few DOM things that are vulnerable to DOM cross-site scripting.
So in other words, someone who wants to do bug bounty or someone who just wants to get into this and learn, there's a lot of opportunities because you can test almost any website because it's used all over the place. And the concern is, like you said, developers who do code don't necessarily understand the security implications of what they're doing, right?
Yeah, and even if they do, even if they fully understand it, even if they're able to filter every single input field, they might forget one. It only takes one parameter to be vulnerable. My very first cross-site scripting I found for bug bounties was hidden in a very deep part of the website. And it was like you had a website, you could create a system. On that system, you could put benchmarks, and in the benchmarks, you had a table which was vulnerable to cross-site scripting. So to come across these things is not easy, but as a bug bounty hunter and a pen tester, it comes down to testing all of the parameters.
It's always nice to learn from someone who's walked the road. So you have courses on Udemy that people can buy, and we'll put links below, but you also do live training, is that right?
Exactly. I do boot camps as well. And also for cross-site scripting, I have one in 2 days. We'll go over all of this stuff, and we'll teach you how to hunt for these, including filters. Like there's one filter where you have to enter an email address, and only an email address is accepted. Well, guess what? You can still enter cross-site scripting there.
Okay, so that's great. So, I mean, someone could like register for your 2-day course. I'll put a link below as well if they're interested in live training. I know you charge very low prices compared to some places. So, I just want to say this. Wesley, since I've got to know him, is someone who really tries to help the community. And often he helps too much because he just wants to help people. So please support him, buy his course below, or go to his boot camps. He's really trying to help the community with what he's doing. Wesley, one concern I have is I don't want to go to your website now. Should I use a virtual machine or something like not my normal computer to go to this website that you've got all these demos on?
No, it's not a problem at all. You can rest easy. There's no cryptocurrency miners on there. I'm not gonna infect you with a bug. And the thing is, if you visit a website, cross-site scripting is limited to that website only. So I'm not gonna be able to execute code on a different website or anything. And especially the reflected cross-site scripting, there's no worries there. You can rest easy.
I'm not sure if I trust you. No, I'm kidding. No, that's great.
Trust but verify. That's what I always say.
Yeah, exactly. Just for everyone who's watching, I'll put Wesley's social media links below. He's big on Twitter. He has quite a big social presence these days. Wesley, I really want to thank you. And I mean, I should call you XSS Rat, but it's easier for me to say Wesley. But I really want to thank you for, sharing this knowledge with us and sharing with the community.
I really want to thank you for having me on. And if anybody's interested in doing cutting edge research, these client-side templating engines that I've talked about, they're very under-researched. So that's a great area we need a lot more people looking into. Thank you very much. Really appreciate it.
Wesley, it's a pleasure. Thanks.